Kia ora koutou, Reese from QuickSense here, and today we're looking at rotational symmetry. Now with rotational symmetry, what we're asking is, how many different ways can I spin an image or a shape and have it look the same? So for example, something like a circle, if I spin it about the center of the circle, there are infinitely many ways I can do that. A circle always looks the same. Whereas something like, in this example here, a square, well, how many different ways can I do it? So we're going to be rotating about the center, and if I pick it up and twist it around, right, it's going to look the same when this corner is on this corner here. So that's what we're going to call a quarter turn, right? So this one, I'll come over here, and then again, we can do it one more time, and then again, and finally, back to where we started. We count that as an order of rotational symmetry. So that's 1, 2, 3, 4. How many orders of rotational symmetry does a square have? It has 4 orders. In this next question, we are asked to make some decisions about which beads to include and which beads not to include, because as you can see here, a total of 16 beads are to be threaded to make a necklace without any gaps. However, we have 8 plus 4 plus 4 plus 2 plus 2, which is equal to 20. So as we can see, there's going to be 4 beads that we're not going to put on this. So we have to ask ourselves, which beads are we not going to put on? Now, what would happen if we put the blue beads on? Well, if we put the blue beads on, there are 2 of them there. At best, right, let's say this is our necklace. I can put one blue bead over here and another blue bead over here. And no matter what happens with the rest of the beads we can only have 1, 2 orders of rotational symmetry. Okay, so if we use the blue beads or the brown beads, we're only going to have 2 orders of symmetry. So with that in mind, we are going to not include the brown and the blue beads. Okay, so I'm going to cancel them out. We are not including these. So we're focusing on the 8 black beads, the 4 white, and the 4 gray. So let's draw up another circle. Beautifully drawn. Okay, so what's the best case scenario? Well, we're going to put, if we have let's go with this here. So with this instance, white's going to be yellow. So we've got 1 white there, and let's think of it like a square. So in this instance, with each white, I can move it 1, 2, 3, 4. And I can do the same with the gray. Right? So I can do the same with the gray. So if this is gray, 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 so we're keeping a hold of that, or maintaining that rotational symmetry of 4. Now, can I do the same thing with the black beads? Let's go, obviously, green for black. Okay, there we go here. And this is saying consecutive beads cannot be of the same color. So can I do this in a way where the black beads aren't together like they would be here? Yeah, I could always put them in the middle here, right? Just in between that, there. And if they're properly spaced, we can see that each quarter, right, is the same. So every time I move it a quarter turn, it looks the same. 4 is also the highest common factor of 8 and 4. It goes into 4 once, and it goes into 8 twice. Therefore, right, the highest possible order of rotational symmetry is 4.